Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzat Shafiz Rimple and my number matric is 2022-602-774 and this is my individual project. This is a 683 that have been done on this semester. There are three types of tests that I have been done. The first one is rebound hammer, UPV test, and lastly the house test. So we're gonna be through the first one test. So this is the rebound hammer test, a way to measure that how strong concrete is without the breaking it. It also called the Schmidt hammer. The tool has a spring inside that push a little weight. When you press the tool against the concrete, the spring push the weight against it. The distance that the weight bounces back tells you how hard the surface is. A scale on the tool shows the number called the rebound number. If the concrete is a weaker, it absorbs more of the weight energy and the weight doesn't bounce back as much, giving a lower rebound number. The rebound hammer tests were usually used to quickly and easily to determine the compressive strength of concrete. The compressive strength is how much pressure of concrete can withstand before breaking. This test is non-destructive, that meaning it doesn't harm the concrete. The objective of rebound hammer, the first one is assessing compressive strength, net quality control, detecting variability, evaluate uniformity, estimating in situ strength, identify area for further testing, non-destructive evaluation, and lastly, field assessment. The project goals, the first goal is assessment of structure integrity, which is to identify any areas of weakness or degradation that may need reinforcement or repair. Second is verify that the concrete being used for meets the required specification and standard for compressive strength. Third is evaluation of existing structure to determine if the concrete has deteriorated and to what extent repairs or reinforcement needed. This is the material of reinforcement. This is the material of rebound hammer. The first method we need to scratch the withstand on the surface of concrete. After we done the scratch it to surface on the concrete that we want need to test, take a piece of paper to point our point A, B, and C. Push the rebound hammer, take it deeply, and just the rebound hammer will be appear. This is the feature and application of this equipment. The features of this rebound hammer was portable and lightweight, whilst it was non-destructive testing and simple operation. The application. This is the estimate compressive strength to provide an estimate of the compressive strength of concrete. The assessing uniformity help assess the uniformity and quality of concrete. Third, detecting weak spot to identify weak spot or areas of poor quality concrete. Third, monitoring concrete deterioration that used in monitor concrete deterioration over the time. Quality control to assist in the control of concrete production in the construction. The data analysis. This is the result that we got on our test. We had a 6 points of it. The first rebound number, the rebound value shows that 34. The second point showed 13. Next is 32. Fourth 36. Same. Next is 13, and lastly 28. In analysis, the rebound hammer test, which measured an average value of 13, was suggested a high concrete strength. Nonetheless, the reliability of this test can be affected by various factors including the surface texture of the concrete, its moisture content, the age of the concrete, and even the proficiency of the operator conducting the test. While the rebound hammer offers a rapid and convenient preliminary assessment of concrete strength, it is crucial to recognize its inherent limitation. For a more thorough and accurate understanding of concrete strength, additional testing methods and considerations should be applied to complement the rebound hammer result. In a conclusion, the rebound hammer test works similarly to bouncing a ball on different surfaces. Stronger concrete like a hard sidewalk cause the mass in the hammer to rebound more, resulting in a higher rebound number, whereas weaker concrete like a sandy beach cause less rebound and a lower rebound number. This test is commonly used because it provides a rapid and non-destructive assessment of concrete strength on site that allowing for immediate decision making without causing damage to the concrete structure. Next, we're gonna talk about the ultrasonic pulse velocity, which is the test is a non-destructive method for determining concrete building integrity by measure ultrasonic wave propagation speed. The technology is beneficial for identifying and measuring the depth of our fracture in concrete. The UPV test analyzes the velocity of ultrasonic pulse to offer vital insight into the material interior state, enabling for early diagnosis of possible structural concern. UPV testing is useful in infrastructure maintenance and preservation because of its precision and dependability, ensuring safety and lifespan. The UPV test is a critical non-destructive evaluation tool that we usually use widely in civil engineering to measure the strength and quality of concrete buildings. The UPV test, which measures the speed at which ultrasonic waves travel throughout concrete, can detect internal faults such as fracture, cavities, and other abnormalities. The features and the application. This feature of ultrasonic testing is a non-destructive testing method that we usually use to detect internal flaws in a material and measure thickness. Key features of ultrasonic testing included the high sensitivity, the capable of detecting a very small flaws of defect within a material. Next is the penetration depth. Ultrasonic also can penetrate deep into materials, making it suitable for testing a thickness of structure. This application of UPV was testing is used to estimate the compressive strength of concrete by correlating pulse velocity with a concrete density and homogeneity. Uniformity check. It assesses the uniformity of concrete mix and placement, detecting a variation in density, void, and honeycomb. Lastly, the quality control. The UPV testing verifies the adherence of concrete consolidation during casting and monitor curing condition. This is the materials of UPV testing. The first one is transponder. The second is the calibration rod. Fourth is an oil. Fifth, the Prosec 133 ponded lab. Fifth is a tube of BNC cable for 1.5 meter. The methodology of UPV. The UPV pulse is generated by transducer in a contact with one surface of the concrete being tested. After traveling a non-distance through the concrete, the pulse is detected by a second transducer on the opposite surface. Convert it back into an electrical signal and electrical timing circuit measure to the transit time of the pulse. The pulse velocity is the calculated using the formula V same goes to L divided by T. Second is the natural frequency of the transducer should ideally be between 20 and 150 Hz. High frequency transducers are better for short path length, while low frequency transducers are suited for long path length. Transducers with a frequency of 50 to 60 Hz are generally suitable for more applications. Third, apply the petroleum, jelly grease, liquid soap, and kaolin glycerol paste are needed to use. For very rough concrete surface, the surface needed to be smooth before placing the transducer. Fourth, for the direct transmission method, a minimum path length of 150 mm is recommended by one unmolded surface. For the surface probing method along the unmolded surface, a minimum path length of 400 mm is recommended. This is the methodology of how to use the UPV test. First, put some oil on transpuder. Put the calibration rod to calibrate first the transducer. Is it correct or
Kat
the
Aero.
system is can be used or not?
Ah, mantap tu, mantap.
After done
Oh,
the calibration,
mantap tu, mantap Zak. Calibrate dulu.
to ensure the
Kan,
measurements
dia
are
dia
reliable, which is essential of maintaining product quality, the meeting the regulatory requirement, and achieve consistent result in experiment and
okey
test.
tu. Okey, habis dah.
This is to increase the
Okey, buat.
confidence that the measurement that we obtain later are accurate and trustworthy.
10 cm. Jangan tarik, jangan tarik. Ha. Dia buat dia standby dulu.
Next, Apply some oil on the concrete surface, then place the transducer on the
Tu
concrete
yang hitam.
surface at the first testing point. The
What that? This
position
one.
the receiver transducer a non-distant away as I measured and marked earlier. Ensure both transducer place equal length from the middle point marked earlier. Initiate the pulse from the transducer. The pulse travels through the concrete and is detected by the receiving transducer. The UPV tester measure the time taken for the pulse to travel between the transducer.
Cuy break pakai
Repeat
daun
the step
nampak.
at 0.1 mm, 100 millimeter, and 200 millimeter for three locations. This is the result for the two of distance for three location. The distance for 100 millimeter for three location. The point A got 136, point B got 160, and point C got 110, rather than 200 millimeter when the highest got number for point A to 131. The point B same goes as 100 millimeter got 116, and point C got a higher which is got 180. For the conclusion, in the table we can see the difference in distance between three different sections A, B, and C. They were located in different range of between 100 millimeter and 200 millimeter. The UPV had shown that on the reading and 200 millimeter on points A, B, and C showed a leading from those points for the 100 millimeter range. On 100 millimeter shows the crack when it's detected by UPV test to the crack and slow of velocity. Last, the, the test of the half-cell test. This test was a method in civil engineering evaluate corrosion activity in reinforcing steel installed in concrete structure. This is non-destructive and essential of preserving structural integrity by identifying earlier corrosion symptom. A multimeter detects a potential difference between the steel and the half-cell electrode on the concrete surface, showing electrochemical activity at the steel surface, and this strategy helps with the preventative maintenance and increase the lifespan of infrastructure such as bridge and building. The house test is a way to check if reinforced concrete might be starting to corrode. It works by placing a special electrode on the concrete and using a meter to measure electrical signal between the electrode and the steel inside the concrete. This helps engineers to see earlier sign of corrosion to fix problem before the worst, keeping concrete structure strong and safe and longer. This is a type of the equipment. The first one is a rebar scanner, second copper sulfate, next napkin, electrode and sponge, fourth electrical lead wire with grounded clamp, fifth is a plastic container. The features and application. These features of a house cells, it was non-destructive, is a non-invasive method that does not damage the concrete or the reinforcement steel during the testing. Early detection to help in earlier detection of potential corrosion in reinforced concrete structure before visible signs appear. Third is simple and quick. The test was a procedure is a straightforward, can be conducted relatively quickly on site. Application, condition assessment of structure. The bridge and overpass evaluate the condition of bridge depth, column, and beam to identify areas susceptible to corrosion, helping prioritize maintenance and repair. Quality control in construction, repair, and retrofitting project guide decision on repair strategy by identify existing or potential corrosion areas before apply protective coating or repair. So this is the preparation work. First, ready the copper sulfate. Next, use spatula to measure the amount of sulfate. Place the copper sulfate in the cup and weight in using a weight meter. Then place purified water and the copper sulfate into the conical flask. Stir it until the copper sulfate is soluble. Connect the house cell digital multimeter to the electrode and the reinforcement bar. Ensure electrode reference are in a good condition and properly calibrated according to the manufacturer instruction. Next, insert the copper sulfate into the electrode. Next, Wet the concrete surface with a sponge of the electrode. Fifth, set the digital of the voltmeter. And lastly, place the electrode on the concrete surface to obtain a result. The limitation by using the voltmeter, one significant limitation of Hauser testing is the requirement for direct access to the concrete surface. This necessitates that the area being tested is exposed and accessible, which can be problematic for structure with buoy or encased reinforcement. Additionally, the concrete surface often needs to be prepared by cleaning and moisture it to ensure reliable measurement. This preparation can be time consuming and might not always be feasible, especially in large or difficult to reach the area. So this is the result that we got for 12 location. Location 1 we got of negative 42.2. Location 2 we got 46.2. Location 3 negative 31.2. Location 4 the best uh, the best result we got 109.2. Location 5 negative 94.8. Location 6 negative 97.8. Location 7 negative 37.9. Location 8 negative 15.7. Location 9 is negative 76.8. Location 10 negative 36.3. Location 11 negative 29.8. Location 12 negative 35.7. In a conclusion, based on the table, we see that the Hauser test result that appear to have been read. Point 12 had increased a voltage to negative 15.7, while the lowest point on fourth voltage reading at negative 109.2, that we can conclude that all the samples detected are likely not be corrosion. I thank you so much and have a nice day.